So as you can see in the previous graphs, there are going to be some places where the function is undefined and it's approaching some particular value, approaching 0 or approaching infinity. And we can talk about these values in these places where it's undefined in terms of what are known as asymptotes. So what we say is the line x equals c, which is a vertical line, is a vertical asymptote of the function f of x if f of x goes to infinity or negative infinity as it approaches from either side. There's a very simple way to determine if x equals c, that line, is a vertical asymptote, because these are going to be the regions where p of x, q of x equals 0, where the denominator equals 0. So if we want to determine where the vertical asymptotes of a rational function will occur, then we just need to find where the denominator will be equal to 0. And so here, to identify the vertical asymptotes for part A, 2 over x minus 3, we want to know where this is undefined. Well, x minus 3 is equal to 0 when x equals 3. And so the vertical asymptote is the line x equals 3. Be careful here, it's important that you include the whole thing. This time it's an equation of a line. Part B, if we factor the bottom, we see that the vertical asymptotes from this function are going to occur when x equals negative 2. That's our first line. And x equals positive 1/3. Finally, for part C, notice that this term will never be equal to 0, no matter what x is. And so this one doesn't have any vertical asymptotes. There are no places here where the function is undefined. Horizontal asymptotes are similar. We say y equals d is a horizontal asymptote if the function f of x approaches some number as x approaches infinity or negative infinity. So as we go really far out to both sides, what value does it approach? One important thing to recognize in terms of a vertical asymptote, this is a line that the function can't cross. So it's a vertical line, it's where it's undefined, it's always going to come close to the line but never cross it. A horizontal asymptote is a line that the function approaches as it goes out to infinity, so it can cross in the middle. Finding horizontal asymptotes is relatively straightforward just by looking at the function. You just have to remember a few things. If the power in the numerator is greater than the power in the denominator, there's no horizontal asymptote. If the power in the numerator is less than the denominator, then y equals 0 is the horizontal asymptote. And if the powers are equal, then the horizontal asymptote is the equation y equals a over b. So the fraction of the coefficients of the two highest powers. So if the highest power is in the numerator, then there's no asymptotes or no horizontal asymptote. If the highest power is in the denominator, then the horizontal asymptote is y equals 0. And if they're equal, it's the fraction of the coefficients of those highest powers. So if we want to determine the horizontal asymptotes here, 4 is in the denominator, 2 in the numerator. Because the power in the denominator is greater than the numerator, y equals 0 is our horizontal asymptote. Here the power in the numerator is greater. So there's no horizontal asymptote there. For part C, the powers are the same. And so the horizontal asymptote is going to be y equals the fraction of the coefficients. So 8 over 2, which is just 4. Remember that these are equations of vertical and horizontal lines, so you have to include y equals and x equals.